In this lesson, we will learn how to factor quadratic polynomials, which are polynomials that can be written in the form ax squared plus bx plus c. So, for example, we will learn how to take a quadratic polynomial like this one and write it as the product of two binomials. To learn how to do this, we must first make some observations. We're going to multiply two binomials where each binomial has the form x plus or minus some constant. We'll use the FOIL method to expand these products, and when we do so, we get the following. Now first notice that all of these products have the same form. First we have x squared, then we have some multiple of x, such as 5x, 7x, and negative 9x, and finally we have a constant term. Now if we examine these products further, we can make some additional observations. For example, here the two binomials feature x plus 3 and x plus 2, and in the product the coefficient of the x term is positive 5 and the constant term is positive 6. Do you see a relationship here? Well, in the next example, we have x minus 2 times x plus 9, and in the product the coefficient of the x term is positive 7 and the constant term is negative 18. In the third example, we have x minus 4 times x minus 5, and in the product the coefficient of the x term is negative 9, and the constant term is positive 20. Now in general, the relationship between the two binomials and the expanded version is that the coefficient of x is equal to the sum of the two constants in the binomials, and the constant term is equal to the product of the two constants in the binomials. Now let's use this to help us factor some quadratic polynomials, beginning with this one. Since this polynomial has the form x squared plus some multiple of x plus a constant term, we know that its factorization will have the following form. Our goal now is to determine the constant terms in the two binomials. To find these constant terms, we have some clues. Based on the polynomial here, we know that the sum of the two constants will be 6, and the product must be 8. So what are two numbers that add to 6 and have a product of 8? If you said positive 4 and positive 2, you are right, so our factorization is now complete. X squared plus 6x plus 8 can be factored to be x plus 4 times x plus 2. Now if we wish to confirm that we have factored this correctly, we can simply expand these two binomials to see that the result is indeed x squared plus 6x plus 8. Okay, how about another example? Once again we have this familiar form, so the factorization will look something like this. Here the clues for the two missing numbers are that they add to 5 and that their product is negative 14. Now notice that the product of the two missing numbers is a negative number. If the product of two numbers is negative, then one number must be positive and the other number must be negative. So we can add this to our factorization. Okay, so what are two numbers that add to 5 and have a product of negative 14? Well, how about positive 7 and negative 2? This means that x squared plus 5x minus 14 is equal to x plus 7 times x minus 2. Okay, here's another one to factor. Once again, we have the usual form, so the factorization will look something like this. Here, our two missing numbers add to negative 2 and have a product of negative 15. So these two numbers must be positive 3 and negative 5. In the next example, the two missing numbers add to positive 7 and have a product of positive 6. So these two numbers must be positive 1 and positive 6. The factorization of the next quadratic polynomial is missing two numbers, and these two numbers add to negative 10, and they have a product of positive 16. So these two numbers must be negative 2 and negative 8. Finally, the two missing numbers here must add to negative 3 and have a product of negative 40. So these two numbers are positive 5 and negative 8. Now on occasion, you will encounter quadratic polynomials where the coefficient of x squared is a number other than 1. In these instances, there is a good chance that these polynomials are versions of the special products that we examined briefly in an earlier lesson. These two special products are such that the first term is a square and the last term is a square. Also, the middle term is twice the product of the square roots of the first and last terms. For example, the square root of 4x squared is 2x, and the square root of 9 is 3. And here the middle term is equal to 2 times 2x times 3, which is 12x. As such, this is one of our special products. These other two products meet the same criteria, so they are special products as well. To factor the first polynomial, we'll take the square root of the first term to get 2x, and we'll take the square root of the last term to get 3. Since this polynomial has the same form as this special product, the two binomials in our factorization will both feature plus signs. The next polynomial can be factored as follows, and this is how we factor the last polynomial. Okay, to summarize. In general, if a quadratic polynomial can be factored in the following form, then the coefficient of x is equal to the sum of the constants in the binomials, and the constant term is equal to the product of the two constants. Also, if you encounter a quadratic polynomial where a, the coefficient of x squared, is not equal to 1, then there is a good chance that it is one of the special products that can be factored as follows.